Hello class, this is Math 1440, section 9.2. Let's just go over this one problem, solving a differential equation. So I want to solve dy dx is equal to xy squared. So whenever you're asked to solve a differential equation, that means you have a derivative in the equation, and ultimately you want to solve it for y. So you always want to solve for y. Okay, so the first step for solving a differential equation like this is to separate the variables. So for our solution, let us separate the variables, and then once we do that, we're going to integrate each side so we can get y. Okay, so how are we going to separate the variables? Here's the plan. I got dy over here, so if I divide by y squared to each side, I'll have y squared on the bottom. And then if I multiply each side by dx, I would have dy over y squared is equal to x dx. So that's what I have here. So we got dy over y squared equals x dx. Now the variables are separated because this is just all y's, and on the right-hand side is all x's. So now that the variables are separated, we integrate each side. So I have the integral of dy over y squared equals the integral of x dx. And now to make this more friendly to integrate, I'm going to bring the y squared up as a y. Well, first what I did was I wrote 1 over y squared dy. That's the same thing as saying dy over y squared. And that equals the integral of x dx. Now, 1 over y squared, bring it upstairs as y to the negative 2 by a rule of exponents. This is more integrable now. So I got the integral of y to the negative 2 dy is equal to the x dx. And now we just use the power rule for integration to each side. So the integral of y to the negative 2 dy, you increase the power by 1 and divide by that number. And that's going to equal, and again, by the power rule of integration, think of x as x to the first. So when I increase the power by 1 and divide by that, I get x squared over 2, plus c sub 1 I wrote. So you only have to add c to one side. So generally, when you integrate y, you don't have to write plus c on this side, because if you just do it on one side, that's good enough. Okay, so as a technicality, instead of writing c, I wrote c sub 1, because I want to save c for my final answer. This is not a big deal at all. Okay, you'll see why I wrote c sub 1 in a second. Okay, and now let's make this more friendly without negative exponents. So isn't y to the negative 1 the same thing as 1 over y? And then what's a positive over a negative? So I got negative 1 over y, just by a rule of exponents, equals x squared over 2, and then I want to get a common denominator of 2. So I multiplied c sub 1 by 2 over 2. So now I got x squared over 2 plus 2 times c sub 1 over 2. Okay, and just to be clear, because I'm gonna set the cross products equal pretty soon, this negative in the front of the fraction is the same thing as putting a negative in the numerator. So I just did that so the next step will be easier to see. So these are equivalent. So I got negative 1 over y, and now since we have a common denominator, for the right-hand side, you can write it as a single fraction with that common denominator. Just add the numerators. So x squared plus 2 times c sub 1 over 2. Okay, and now, a little fancy footwork, I'm going to say let 2 times c sub 1 equal c, because c sub 1 is some constant. And then 2 times that constant is just going to be another constant. So let's call that new constant c. That way I'm going to have my final answer in terms of c. And now what I want to do is set the cross products equal. Because whenever you have a fraction equaling a fraction, let me go down here. A fraction equaling a fraction, you set the cross products equal. So what I did was I started with this y and I did a cross product. So y times the expression x squared plus, and then just write c, because we just said let 2c sub 1 be c. So I got y times x squared plus c, and then the other cross product, 2 times negative 1 is negative 2. And remember, when you're solving a differential equation, that means you want to solve it for y. So just divide each side by x squared plus c to get y by itself. So I have y equals the negative 2 over x squared plus c. And we are done. We solved the differential equation because ultimately we solved it for y. And it just looks nice instead of having a c sub 1 in your final answer to have a c. But it's really not a big deal. All right, I'll take an overview of this problem. So here again, here's the problem in its entirety. So it was not too many steps there. Solving a differential equation, meaning that you see a dy dx. Sometimes they can be a little tricky, like this top. Sometimes you might see, instead of dy dx indicating a derivative, first derivative, you might see y prime. So that's a little tricky. If you just see y prime, then the first step is to rewrite y prime as dy dx. So if you have a y prime and you're asked to solve the differential equation, rewrite y prime as dy dx. So that way you can separate the variables. And by separating the variables, that means you want y's on one side, x's on the other side of the equal sign. And once you accomplish that, then you integrate each side. And whenever you integrate, you try to rewrite the integral so that way it's easier to integrate when that applies. And then once you do the power rule of integration, drop that integral sign because you don't want to integrate for the rest of your life. So when you integrate, drop the integral and the dy. These appear together and then they disappear. And only write plus c or plus c sub 1 on just one side of the equal sign, preferably the right side. Because ultimately I want to solve for y, so why have a plus c next to it? It makes it harder to solve for y that way. Okay, I guess that's it for today. So good night and have a good week. Bye-bye.